Hi, in previous video, we saw the detail on Dbscan and its application. Now, the idea of density-based clustering. The basic idea of density-based clusters. The basic idea of density-based clusters can be generalized in several ways. First, any any notation of a neighborhood notation of a neighborhood can be employed instead of a distance-based uh, neighborhood as long as the definition of neighborhood is based on predict n p2, which is symmetric and reflexive. The neighborhood n of p, the neighborhood n of p The neighborhood n of P is then defined as set of all points Q satisfy in predict PQ. Second, instead of simply counting the elements in a neighborhood, more we can as well use a more general predict and weight to determine whether the neighborhood n is dense if minimum weight is monotone. Yeah. That is, if minimum weight is satisfied for all subsuperset of sets that satisfy n, finally not only point-like objects but also spatially extended objects such as polygons can be clustered when clustering polygons. For example, the following predicates are more natural than the EPS neighborhood under the min weight minimum points. Coordinate constraints predict x, y if intersects x, y and minimum weight n. If delta p of n population b minimum population, the Dbscan algorithm for finding generalized density based clusters in a straightforward extension of the Dbscan algorithm. Algorithmic step for Dbscan clustering. Here, let x is equal to x1, x2, x3 of and up to x1, xn. With a set of data points, Dbscan requires two parameters, that is EPS and the minimum number of points required to form a cluster minimum points. Start with an arbitrary starting point that has not been visited. Extract the neighborhood of these points using all points which are within the distance or neighborhood. If there are sufficient neighborhood around this point, then clustering process starts and the point is marked as visited, else this point is labeled as noise. Later this point can become the part of the cluster. That is, if a point is found to be a part of the cluster, then its neighborhood is also the part of the cluster, and the above procedure from step 2 is repeated for all summation neighborhood points. This is repeated until all points in the cluster is determined. A new unvisited point is retrieved and processed, leading to the discovery of a further cluster or noise. This process continues until all points are marked as visited. Parameter estimation. Every data mining task has the problem of parameters. Every parameter influences the algorithm in specific ways. For Dbscan, the parameters E and minimum point EPS and minimum points are needed. Minimum points. As a rule of thumb, a minimum points can be derived from the number of dimensions D is the data set as minimum point greater than D plus. The low value minimum points equal to 1 does not make sense, as then every point on its own will already be a cluster. With the minimum points equal to 2, the results will be of same as a hierarchical cluster. The single link metric with the dendrogram at a high height, therefore minimum points must be chosen at least 3. However, larger values are usually better for data sets with noise and will yield more significant clusters. As a rule of thumb, minimum points equal to 2 dimensions can be used, but it may be necessary to choose larger value for large data, for noisy data, or for data that contains many duplicates. EBS. The value of E can be chosen by using a k distance graph, plotting the distance to the k minimum points minus 1 nearest neighbor order from the largest to the smallest value. Good values of EBS clusters will merge and majority objects will be in the same cluster. In general, small values of E are preferable. And, uh, and, uh, as a rule of thumb, only a small fraction of points should be within the distance of each other. Distance function, the choice of distance function is tightly linked to the choice of yes, and it has a major impact on the outcomes. In general, it will be necessary to first identify a reasonable measures of similarity for the data set before the parameters that can be chosen. There is no estimation for this parameter, but the distance function need to be chosen appropriately for the data set. This is parameter estimation. Yes. Denuclear. Let's go on Denuclear. Denuclear takes another approach to generalize the notion of density-based cluster based on the concept of influence function. The mathematically model the influence of a data points in its neighborhood. The density at some point is estimated by the sum of about the influence of all data points. A point is said to be density attracted to a so-called density attractor if they are connected through a path of high density points. An influence function should be asymmetric, symmetric, continuous, and differential. Untypical examples of influence function are square wave function or Gaussian function. The density functions at a point x is computed as the sum of the influence function of all data points at point x. Density attractors are points that correspond to local maxima of the density function. A point P is density attracted to a density attractor Q if Q can be reached from P through a path of points that lie within a distance of EPS from each other in the direction of gradient. An arbitrary shape cluster for a set of density attractors X is then defined as a set of all points that are density attractor to one of the density attractors X from X, where the density function at X exceeds a threshold. In addition, all pairs of density attractors need to be connected to each other via paths of points whose density meets the same threshold. The parameter implied by the basic influence function determines the reach of influence of a point, while the parameter specifies when a density attractor is significant. Note that the Denuclear clusters became identical to the Dbscan clusters when choosing the square wave influence function with the EPS and the minimum points. The efficient implementation of Denuclear algorithm is based on the observation that most data points do not contribute to the density function at any given point of the data space. This can be exploited by computing only a local density function while guaranteeing tight error bounds. To efficiently access neighboring points, a so-called map data structure is created. A dimensional grid structure of grid length to only grid length. Only grid cells that actually contain points are determined and are mapped to one-dimensional keys, which are indexed. Example, in a B plus tree, to determine the density attractors for each point in a grid cell. A hill climbing procedure based on the local density function and its gradient is used. After determining the density attractor X star for a point X, the point X is assigned to cluster including X star. Some heuristic allows the algorithm to assign nearby points without having to apply the hill climbing procedure. This is Denuclear. Thank you.